Now let us continue with the study of different types of electrical pressure transducers. Now let us move on to third type of electrical pressure transducer is inductance type pressure transducer. In case of inductance type pressure transducer, the applied input pressure is measured in terms of change in inductance of the coil. So basically there are three types of inductance type pressure transducer which we are going to study in this section are current sensitive coil type, LVDT type and reluctance type. So let us see first one, current sensitive coil type inductance pressure transducer. So it consists of mainly three parts. One is coil, second one is a movable magnetic core, then third one is the elastic deformation element, and this element is attached to the core. When the input pressure is applied to the core, when the pressure varies, the element causes the core to move within the coil. An alternating current is passed through the coil simultaneously, and as the core moves, the inductance of the coil changes. The current passing through the coil increases as the inductance decreases. So that is why this type of transducer is also called as current sensitive coil type transducer. And here the applied pressure, since when pressure is applied, the current flowing through the coil changes because of the change in the inductance of the coil. So the measured current will give the value of applied pressure. So in order to get increased sensitivity, the coil may be divided into two turns using a center tap. As you can see in this figure, the coil is divided into two parts with a center tap. So this actually provides two coils. As the core moves inside the coil, the inductance of one coil decreases as the inductance of another coil increases. So when pressure is applied, when core moves in the upward direction, the inductance of the lower coil decreases because more amount of core is linked with the upper coil and less core is linked with the lower coil. So therefore the inductance of lower coil decreases and the inductance of upper coil increases. So because of this change in the inductance, the current flowing through, the current across the coil also changes, and we can measure either change in the current or else change in the inductance can also be measured directly with the help of inductance measuring bridges. And this value of change in the inductance gives the value of applied pressure. Now let us see another type of inductance type pressure transducer is LVDT type, that is linear voltage differential transducer type. So in this case there is a movable core around which the windings, the primary winding and also the secondary windings, which are split into two parts, are wound. And movable core is connected to bellows to which external pressure is applied. Now this pressure is to be measured. So here the AC supply is applied across the input primary coil, and the output secondary coils are, as I told, the output secondary coils are split into two equal parts. So at normal position the movable core is at the center. So now when pressure is applied to the bellows, So it moves the movable coil. It moves the movable core in the forward direction. So therefore, less amount of core will be linking with the secondary coil 2 and more quantity of core is linking with secondary coil 1. So therefore, the inductance of secondary coil 1 increases and the inductance of secondary coil 2 decreases. So this difference in the value of inductance between these two secondary coils is measured, which gives the value of applied input pressure. Conversely, if the pressure is applied in the backward direction, then obviously the inductance of secondary coil 2 increases and inductance of secondary coil 1 decreases, and again this difference will give the value of applied pressure. So the polarity of the inductance or the polarity of the change in the output voltage across the secondary coils will give the direction of applied pressure. Now let us see the third type of inductance type pressure transducer is reluctance type inductance pressure transducer. So this is the general diagram of reluctance type pressure transducer. So here it consists of a movable armature which can be moved towards the permanent magnet and away from the permanent magnet based on the direction of applied pressure. And there is a permanent magnet. On one of the limb of the permanent magnet, a coil is wound. So here the electrical energy is provided by the field of a permanent magnet rather than AC source. We are not connecting any AC source here. For pressure measurement, the elastic deformation element moves this armature closer to or farther from the permanent magnet. The reluctance of the coil, which is wound around the permanent magnet, changes with the movement of the armature. As the armature is moved towards the permanent magnet, when pressure is applied towards the permanent magnet, then the reluctance of the coil increases, and when the pressure is applied away from the permanent magnet, the movable armature moves away from the permanent magnet and the reluctance of the coil decreases. So therefore here the input applied pressure is measured in terms of change in the reluctance of the coil. So this is the reluctance type inductance pressure transducer. Now let us see the fourth type of electrical pressure transducer is capacitive type pressure transducer. So in case of capacitive type pressure transducer, the applied pressure is measured in terms of change in the capacitance of the capacitor. So this is the diagram of capacitive type pressure transducer. Here it consists of two flexible plates of capacitor. This is the upper plate and this is the lower plate of capacitor, and these two plates are flexible. And there is a dielectric medium which is fluid. So fluid whose pressure is to be measured is acting as dielectric medium between the two flexible plates of a capacitor. So now as the pressure of the fluid is increased within this capacitor system, when the pressure of the fluid increases, then the flexible plates of the capacitor expands, and therefore the distance between the two plates increases. As the distance between the two plates increases, so obviously its capacitance value changes. That change in the value of capacitance is measured with the help of any instrument which can be used to measure change in the capacitance, or else we can use the bridge like a de Sauty's bridge or shearing bridge, which can be used to measure the change in the capacitance. So therefore the value of pressure of the fluid is measured in terms of change in the capacitance of this capacitor system.